Let's cover chapter 9.2, the real numbers system. You basically know most of this already. We've discussed the real number system. This is where we have our circles like this. And then inside this circle right here, we have our natural numbers. Remember that? Then we had our whole numbers right there, our integers, which is our positive and negative numbers. And last is our rational numbers. Remember, natural numbers are numbers like 1, 2, 3, 4, 5, 6, 7, on and on. Whole numbers are natural numbers, including 0. Integers are whole numbers and their opposites. And rational numbers, remember, includes all numbers that you know. Decimals, fractions, whole numbers, integers, naturals. It's all inclusive of them. And remember this circle, this is our irrational. Remember, to identify a number, you need to simplify it first, okay? The only reason we're going through this yet again is because now we're introducing square roots. We've already talked about it since chapter 1, but now it's being officially talked about in chapter 9. Remember, they're all real numbers. And on the outside of our box is imaginary numbers. And we'll talk about that just briefly, but that's not something you'll be tested on ever. Remember, in your book, natural numbers is the letter N, whole numbers is the letter W. Integers, remember, integers are not for I, it's a Z, and for rational numbers, it's a Q. So don't forget that, because irrational numbers, that's your capital I. Again, that's in your book, so you could follow that as well. Again, we go back to knowing your square roots. Make sure you know them and know how to classify your numbers. So if I said to you, all right, what does the number 7 represent? You're going to start in the center and say, it's natural, yes. Once you say yes to natural, it's yes to all of them. So it's N, W, Z, and Q. If I had this number and it was repeating, I look at that and I go, okay, I know that as a fraction, because you guys know if one number repeats, it's over, and this is where you would raise your hand and tell me 9. So if it can be turned into a fraction, then we know it's a rational number. It's not natural, it's not a whole number, it's not an integer, but it is a rational number. So this one would only have a Q. Okay. If I had the negative 3/4, again, it's a fraction. Fractions are rational, and that's it. It's not an integer, because remember, an integer has to be a whole number. Now we're going to add square roots. So if I gave you the square root of 49, you have to simplify before you identify. You would say that that's equal to 7. And if I say that's equal to 7, then you know it's all of them. It's a natural, it's whole, it's an integer, and it's rational. But if I gave you the square root of 12, that's not a perfect square. And if it's not a perfect square, that means it goes on forever and ever and ever and ever and never repeats and never terminates. And in that case, that makes this irrational, or I. Okay? So you're going to be identifying numbers. Another thing that you're going to be doing in this section is comparing numbers. Just like we've done before, the only difference now is we're comparing with square roots. So you need to get it in the same format in order for you to compare them. So if I have 6 4/5, if I have 6 4/5, and I want to compare it to the square root of 48. Now, you don't have a calculator, so you're going to have to do some estimating, and some of these are going to be really close. But I just want you to get an idea and feel comfortable with estimation. So it's up to you if you want to leave this as a fraction or think of it as a decimal. This is a benchmark fraction, so you can clearly and easily take it into a decimal. This one, like I taught you in 9.1, I want you to think about the two perfect squares that this is between. It's between which two perfect squares? 49 and 36, correct? So it's between 6 and 7. And I'm pretty sure you would agree with me that it's closer to 7. So I probably say this was like 7.9. It's like 1 point away from being 49. So 7.9. So when you look at this, they're really, really close, but clearly this is slightly higher because we know it goes on forever, and it's definitely closer to 7 than it is to 6. So that's how you want to compare those numbers. So you really want to make sure you put them in the same format. If I had the square root of 74 and I was comparing it to negative 8 4/10 repeating, same thing. Look at the square root of 74 and say, all right, that's between which two perfect squares? (64 and 81). So I have the square root of 74. And I want to think about, is it closer to 8? Sorry. Or is it closer to 9? So we have to figure out what's the distance between here and here, and then what's the distance between here and here, and which one is closer to it. So when I look at this, I can see that it's closer to here to being like 8 3/10 maybe. Negative, sorry. And this is a negative. So actually, no, it's close. Let's see. So how far is it from 64 to 74? It's actually closer to the 9, isn't it? So it's probably like 8 6/10 if we really wanted to think. And remember, these are negatives. And because they're negatives, this is actually the smaller number. And how did I figure out it's closer to 9? Because there's 10 jumps here, there's about 7 jumps here. 10 from here to here, 7 from here to here. So it's past the halfway mark. So it's got to be closer to the 9 than it is to the 8. So that's how you're going to do that problem. I also went over this problem in 9.1 with a square, but I'm going to show you without a square. So if I gave you y squared equals 25, and I said to you, solve this equation. This is an equation. I said this before to you. The only way to undo a square is to square root it. So I'm going to take the square root of both sides, and I get y equals positive or negative 5. And I have to say positive negative 5 here. There's no story attached to it. So it's not attached to a square. If I gave you a picture and I said to you the area of the square was 25 units, then you would say 25 is equal to side square. I would do the square root of both sides, and I would say that the side is equal to 5. But I wouldn't say negative 5 because it's a square, and a side cannot be negative. This problem doesn't have a story. And because it doesn't have a story attached to it, I need to include the positive and the negative value. If I'm going to do a problem like this, m squared is equal to 74. Again, the only way to undo a square is to square root it. And I'm going to have m is approximately, because that's not a perfect square. So I got to go over here, and I have to find out what two perfect squares is 74 between. So let's see, 8 times 8 is 64, and 9 times 9 is 81. So it's between these two perfect squares. Is it exactly halfway? So I have the square root of 74. Is it exactly halfway? No. I would say that it's slightly closer to 81 than it is to the square root of 64. So I'm not going to say it's, remember this is 8 and this is 9. I'm not going to say 8.5 because it's not halfway. It's just slightly closer over here. So I'm okay with you saying 8 6/10 would be a better answer. So you're going to say positive, negative 8 6/10. Again, estimation, just as long as you're close. If you would have said 8.6 or 8 7/10, both of those are fine. If you would have said 8 5/10, I would have said no, because it's not directly halfway between those two perfect squares. If you would have said 8 8/10, I would have said, no, that's a little high, because it's not right on top of the square root of 81. It's a little bit greater than halfway, but not close, that close to the square root of 81. I hope that makes sense to you and you're able to do your homework. Remember, when I look at this right here, you have the answers in the back of the book. Make sure you check your answers. Make sure it makes sense to you. Make sure you're showing your work as much as possible. So when you start to do your 9.2 homework, chapter 9.2, make sure you put your numbers on there. Starting with problem number 13, you're going to go 8, and then you're going to say, well, yep, that's a natural number, that's a whole number, that's an integer, and it's rational. Now you're on number 15. Easy as can be. Then you're going to do all of those up to 27, and then you have a couple of always, never, sometimes problems you should do. Then you're going to get to question number 33, and you're doing your greater than, your inequality signs, and your equal sign. So 33 is 5 1/4 compared to the square root of 26. Don't guess. Do not guess. Use some rationale so that you understand the numbers that you're working with. You know that this is 5 1/4. This is not a perfect square. You know it's between the square root of 25 and the square root of 36. So it's between 5 and 6. It's really close to the square root of 25, right? So it's not halfway, so it's not going to be 5 5/10. It's going to be more like 5 1/10 as an estimation. So 5 1/10, and they're both positive, so you're going to clearly see that that is greater. That's what I should see on your homework. I want to see your thought process. Don't guess. Then you're going to do some more problems like that, and you're going to get down to problem number 45. I'm sorry if you're getting a headache from me holding the phone and shaking it. Next time it'll be better. A squared equals 49. The only way to get rid of a square is to square root it. And here's the thing that I don't want you to forget. This is not a story, and because it's not a story, you have to say positive, negative 7. It includes both of them, because negative 7 times negative 7 is positive 49, and 7 times 7 is 49. Okay? I hope that all makes sense to you. I hope you're able to do your homework better now that I'm doing this video instead of you having to watch a video that I found. For sure, on Friday when I come back, we will go through all of this together and hopefully clarify any questions that you had. This will give you the opportunity to watch this again and again and again. How exciting for you. And hopefully clarify any questions that you have. Email me if you have questions, or we'll just talk on Friday. See you soon.